All right, so today we're talking about linear equations. And there's three different kinds. There's this kind, which I would say you don't see as often, but it would be like 3x plus y is equal to 5. See how the x is first and then the y is next, and then the last thing is called a constant? That's standard form of an equation. They use it some, but you don't use it a lot. You do use this one a lot. Y equals mx plus b. Raise your hand if that one's familiar to you. All right, good. Yeah, you use that one a lot, and that one's the one where this is the slope, and that's the y-intercept. Okay? The next one is a really important one that I don't think you use very much up till this point. So tell me, how many of you would say, yeah, I remember that one, I know that one, I'm good at that one? Okay, that's about 10% of it. So this one is powerful, and we need to learn how to do this one today. Like when you go on to pre-calc, which is probably what you'll take after this. This is like day one. We're using this, and it's important to know in pre-calc too. This one, everybody, copy that one down if you haven't already. Y minus y sub 1 equals m times x minus x. And it's really, really handy for if you have a point, you put the point in here and here. The x goes under the x, and the y goes under the y. And if you have a slope, the slope is still m, so that's kind of handy because it's the same as that m right there. So its slope goes there. And then, when you've done that, you have a point and you have a slope, and you stick them all in, you've got the equation for the line. This is a really common ACT kind of question. We've got a point, this, comma this. We've got a slope of this. What's the equation for it? Or they might ask you to not only have the equation, but like figure out some other point that's on the line. But that's easy once you have the equation. All right, so point 2 comma 5. Slope, let's see, slope m equals 6. If I was going to use this thing, I would say y minus, I'm going to put an empty spot, equals empty spot for where the slope's going to go, times x minus empty spots. All I did is leave empty spots where I'm going to drop in the point, and then I'm going to drop in the slope. So the point goes here, x of it is 2, y of it is 5, and then the slope 6. There it is. Now a lot of you are going to say, but that doesn't look like an equation I'm used to. I know, you're not used to it. What you're used to is y equals 2x minus 7. But this is the same thing. It's just not solved for y yet. A lot of kids think they have to solve it for y. Nope. It's good enough just to leave it the way it is. The only reason that you really need to get it solved for y would be, I'm going to add 5 to both sides so I can get y alone, would be now you could put it into a calculator. See, because it says y equals, and then you've got that screen on your calculator where you can type it in if it's in y equals. Again, this isn't what you're used to. You're used to if I multiply this all the way out, but I don't need to do that to put it on the calculator. I could put it in just the way it is. Okay? And I can still see the slope from this, can I? What's the slope? 6. It's right there. And I can still see the point. That's the x of the point. And the other one's the y of the point. We just have to be a little careful about whether that 5 is positive or negative. All right, so let me go the other way. Let's say I gave you an equation and I said like this. Y minus 7 equals 4 times x plus 2. Could you please write down what you think the point and the slope were? And I threw in a little gotcha, so see if you can not get fooled. This is called coordinate geometry. And about 14 questions out of the 60 that are on your ACT test that you'll take someday, about 14 of them are on this. Not this exact thing, but coordinate geometry like this, where they give you points, they give you slopes. They give you 2 points, and you got to figure out the slope. 2 points, and you got to figure out the equation for the line. All right, hopefully you knew that was the slope, and then who's got the point? Mr. A in the back. And you caught it. Nice job. Because that's negative, because normally there's a minus right there, and there was a plus there, which means it must have been a minus, to make it work. So yes, it's a negative 2 comma 7. Okay? All right, so in other words, if they have a minus, that's kind of the normal way it should be, and then you can just pick the number as it stands. But if there's a plus, that's not the normal way it should be, so it should be the opposite of what you would think. All right, so there's my slope, there's my point. All right, what if they give me 2 points? 2 comma 5 and 3 comma 7. You get how pretty quickly I could figure out what the slope is, and then I have a point and I have a slope, and I could put it into that formula. All right, so let's just one thing at a time. Do you know how to figure out the slope on this? Good. Do it. Figure it out, write it down. I'll see how many of you are right. At this point, I'm going to hand out centios so we can see what you guys' opinion is on what the answer is. We have our answer here for the slope between these 2 points. And you can either do it by taking 7 minus 5 and then 3 over 3 minus 2, or 5 minus 7 over 2 minus 3. And either way, the answer was 2. All right, so let's move on. Take a look at this one. Is this in slope-intercept form? No. Is anybody smart enough to tell me what form it is in? Yes, you are correct. It's standard form. It's got the x first and then the y and then a number. All right, so now, how do I get it to slope-intercept? Pretty simple. Yes, and then I'm going to, so big picture, I'm going to solve for the y. Yes, and you're right. The first step is subtract 3x on both sides. And then I'd have negative 4y equals negative 3x plus 8. Notice I left the x first because when it's all said and done, I want the x first and then the 8 last. Divide by negative 4. Here's one people forget. You got to divide all of them by negative 4. And then I've got y equals, and the 2 negatives cancel, positive 3/4 x. And then 8 divided by 4 is 2, but it's negative 2. You get how I did that? You feel comfortable with that? I just solved for y. All right, now it's in slope-intercept. Because here's the slope, and here's the intercept. All right, moving on. Graphing linear equations. Y is a tough thing to graph because you're used to having a slope and everything, and this has no slope. So how do you graph that kind? Can you look for the y-intercept? Well, I suppose you could look at the y-intercept is at negative 3, so it's there. But is that a line? No, it's a dot. So what do I do now? Yes, sir. Okay. It's either straight across or straight up and down. So now, just ask yourself this question. If there was a slope in here, would it be more like a 0x? Or would it be more, that's like a slope that's totally flat? Or would it be more like an infinity x, which would be a straight up and down slope, which has a slope of infinity? Which makes more sense to you, that it was a 0x or an infinity x? You're not getting what I'm trying to say. How about this? Y equals 0x minus 3. Do you get 0x would be just 0 and it would disappear? So do you get how I could kind of say it? There's a 0x in that equation. And that tells you what the slope is. What's the slope? And if it's no slope, then it's like super flat, right? So it's like this. All right, so anyway, that's how you do the y one. What if it's x? Well, first of all, you got to get x alone. So you divide by 2, x equals 5. And now, that's the exact same thing? No, because it's x. So it's pretty obvious we're going to have to do it the other way. X is 5 is right here. 3, 4, 5 right there. And now it can't be a straight across line. It's got to be an up and down line. It is easy to confuse those two because, you know, when I just showed you, now it's fresh in your mind, but it might be easy to think that they go the other way. So just be careful with it. All right, moving on. Let's say I had to graph 1/2 x. This one's got a slope, but it doesn't have a y-intercept. Or does it have a y-intercept? It does. What is the y-intercept? 0. So therefore, it just goes through here. And then it has a slope of 1/2, which means it rises, what? 1, and then it runs 2. Okay, so rise 1, run 2 goes there. Rise 1, run 2 goes there. And then you get the idea, and you can draw the lines. All right, this is another special situation. If you want to graph this one, could you solve it for y and do it that way? Yes. It takes a while. There is another way. And this way will always work. Every complicated equation, it's just sometimes slow. But this way will always work. Let's make an XY chart. And I ask myself, what number, if I stick in a number for x, like 0, then what number would y have to be? So 0, 2 is on my list of points that are on this line. What else would work? Well, I could stick in 0 here, and then what would x have to be? 3. So it'd be 3, 0. There's another point. And you know what? Once you have 2 points, you know what you can make? A line. All you need is 2 points. So 0, 2 is right there. 3, 0 is right there. And now I just have to connect them. Now, would it be smart to check one more point? Yeah, if my life depended on it, I wouldn't want to just trust those two. I'd probably try one more point. So what if I said x was -2? And that would be -4 plus 3y equals 6. So I add 4 to both sides, that would be 10. That's not going to work out really good, because 3 times something will have to equal 10. So that one isn't going to work. So maybe I should stick in -3. That would make -6. And then -6 plus what would be 6? This would have to be 0. So then y would have to be 0. I found one. -3, 0. So over to -3. I must have screwed something. Oh, I get it. I tried to do too much in my head. You know what happens when you try to do too much in your head? You get it wrong. Even if you're the math teacher. I add 6 to both sides. I should subtract 6. Add 6. And then 3y equals, add 6 to both sides. I got 12. And there we go. X must be, so y must be 4. So if x is -3, y is 4. 1, 2, 3. Y is 4. There it is. Looks like it's on my line. So I think I did it right. Okay, I'm just trying to show you that other way. I know most of you are going to, when you see this on a test, you're going to just solve for y and you're going to graph it. And that'll work. Because then you'll have a slope, you'll have the y-intercept. I just want to show you another way. All right, moving on. If I was going to graph this one, the slow way would be to solve it for y. The fast way would be to use what I told you a minute ago. Didn't I just show you how to do these? Where what's that? That's a point. And what's that? The slope. And so the point here is what comma what? Careful now. What's that? -4, and that one gives me 2. So -4, 2. 1, 2, 3, 4, 2 is right there. And now I have to have a slope of 3. So I know what about slope? Rise and run, right? So if my slope is 3 and I just have a dot, well, I just go rise 3, run 1. Rise 3, run 1. See how I didn't need to have any more points? If you just tell me one point and you tell me the slope, I can make unlimited points. Alright, so that's how to graph that kind. Find your point, find your slope, use them. Alright, this one, I'd probably just solve it for y. Why don't you solve it for y and sketch it quick? Since you've been watching me for a bit here. Solve it for y. Be careful with that negative. And then sketch it. Alright, so on this one, what you should have done was get the y alone. So I'm going to subtract 2x from both sides, minus 2x, and I have -y equals -2x plus 10. Is it alright to just graph it that way? No. Got to get the y alone. How do I do that? Don't try to subtract a y. That doesn't work. Divide by a negative works. Okay, if I divide by a negative, it'd be y equals positive 2x minus 10, and then I go to -10 down here, and then I have a slope of 2, rise 2, run 1, rise 2, run 1. Approximately like that. Raise your hand if you had that. Okay, good. All right, moving on. Let's take a little Centio assessment. And I would like you to do this one, entering it as a decimal. So figure it out, solve it. Once you got it done, it'll be a decimal, and I'll have you put it in on Centio. All right, we're at 27 out of 31. I'm going to say that's good enough. So let's go to show. Ooh, got a big discrepancy. We got a lot of little answers that are probably wrong, and one answer that's like really common for a lot of kids. All right, so if I show my bar chart, okay. There's one person answered higher than everybody else, and the high, looks like the biggest number is probably the one that was closest. All right, so let's view overall results. Okay, that's not too bad. I'll do this different. Here, I think I am just going to answer it and see what was most common. Okay, we should just go 6 times x, 6x, 6 times 5 is 30, negative 5 times 3x is negative 15x, positive 10 equals x plus 5. Anybody find a mistake in there? Okay, there was an oops. Next, I'm going to put things together. This and this go together, and that makes it, let's see, negative 9x, and this together go make 40. Negative 9x plus 40 equals x plus 5. Anybody make a mistake in there? Okay, thanks for being honest. Next one is, I'm going to get rid of the smaller of these two. That one's smaller than this one is, so I'm going to get rid of that one. Add 9x to both sides. 40 equals 10x plus 5. Anybody make a mistake in there? All right, one person, thank you. And then the next one is subtract 5 from both sides. 35 equals 10x. And, whoo, lively marker. And then x must equal 3.5 was right. A lot of little steps. And I'm happy that the vast majority of the class got it right the first time. If you didn't, saw a lot of kids seeing what their mistake was. That's the key, is if you don't get something right and you understand what you did wrong, then you're halfway there. All right, we do not need to do another one of those. So we already did one like that. We did not need to do another one of those. Or that. That's the same exact thing. We beat that to death. All right. So, I want to talk over a few other possibilities. Sometimes you get a number for your answer. But sometimes your answer is infinite solutions, and sometimes your answer is no solution. I know this comes up on the ACT test. I did like 12 of them this summer to make sure I really understood that test, because I know it's important to you guys in the future. So let's talk about when those come up. 3x equals 3x. Can't argue with that. But what's the answer to it? Infinite solution. Or all real numbers is another good solution. Okay? Because when you're all done with it, you get a fact. If you solve this, I'm going to get 3x from both sides. Can I do that? Yeah, I can. And I get 0 equals 0. Is that a true statement? Yeah, if you get a true statement, then that answer is also all real numbers work. Now, are there some situations where 3x would equal 3? Yes. If x is what? 1. X equals 1. That's only got one solution. Okay? Now let's try one of those kinds that has no solutions ever. That's like saying 3x is equal to 3x plus 5. You can't find a number that could work for this. How do I know that? I'm going to just use my rules. I can do this. I get 0 equals 5. If you ever come out with a true statement, everything works. If you ever come out with a false statement like that, then what do you think it is? Nothing. No solution. Another way I saw it written on an ACT test was the solution set is empty. It's another way to say there are no solutions. All right. So your homework is the little worksheet that I have. I did have that packet that I gave you yesterday, and if there's anything in there that you have trouble with, I just like to offer that you can come in the morning or during this work time. I'd be very proud of you if you didn't understand something, if you asked me about it, so that shows if you're asking me questions, that does not show you're dumb. You know what that shows? It shows you actually care. You get what I'm saying? Because there's a lot of kids who will not know how to do something, and they will really not care. I'm fine, I guess I don't care if I know that or not. So asking me a question shows me that you care about learning it, and teachers are suckers for that. We love it if kids actually want to learn stuff. So please, don't ever feel like, I'm going to belittle you for asking a question like, you didn't learn that last year? I won't do that.